The race to win wars and explore the stars have created some of the most fantastic products ever designed, and we use them every day, unaware of their amazing origins. On Wicked Inventions. Auto-injectors, a life-saving solution originally developed to combat chemical warfare. Satellite TV, how the military space race brought us live television. Memory foam, developed for space but keeping us comfortable on Earth today. We reveal the amazing science and manufacture behind these wicked inventions. In the heat of battle, how can soldiers and civilians be treated fast and safely with potentially life-saving doses of drugs when there are no medically trained personnel to hand? How can astronauts 250 miles away from the nearest hospital treat themselves whilst orbiting the Earth? The answer lies within a small pen-shaped device, the auto-injector. They save millions of lives every day, all over the world, and can be used by almost anyone. The auto-injector is a medical device designed to give one single dose of a particular drug, or, in some cases, multiple drugs. Most of these injectors are relatively simple, spring-loaded syringes. These magnificent devices serve a dual purpose. They're extremely simple to use and also overcome any hesitation associated with needle-based drug delivery devices. The first time a self-injection device was developed was during the 1940s, towards the end of the Second World War. These self-injectors allowed soldiers to self-administer drugs much more efficiently than had been previously possible. However, they were nowhere near as comfortable to use as their devices today.
Auto-injectors are developed really to help the delivery of injectable drugs, and so traditionally these would have been delivered with a pre-filled syringe, which is very fiddly for the user. You can have a needle that's difficult through military uniforms, obviously in a very stressed situation, so this can be very difficult to deliver these drugs.
In the late 1950s, these injectors were developed further as an alternative to exposed hypodermic needles. The needle was covered for safety, and the injector therefore began resembling the pen-like auto-injector devices of today.
So these are very robust devices, can stand being in a battle situation, and then enable the drug to be very easily delivered either by the patient themselves or by someone who's with them.
In 1959, the US military requested the Rodano Research Corporation to develop a new auto-injection system to become an antidote for nerve agent poisoning, a growing concern for the military that needed addressing. It was such a useful and impactful invention that during the 1960s, NASA requested auto-injectors to equip their medical kit, in order for the astronauts to use them easily. From its glass and metal origins to its plastic and safe reinvention, the auto-injectors have been hailed as one of the most important medical inventions of the 20th century. Their use now stretches far beyond the military to more day-to-day medical concerns, such as treating extreme allergic reactions, diabetes, anemia, and rheumatoid arthritis. Today, SHL, a world-leading developer and manufacturer of auto-injectors, are a great example of how these wicked inventions are produced.
So SHL was founded in the early 90s and produced this first auto-injector in 1995.
Over the years, we have launched over 30 auto-injector and pen injector devices commercially, with many more in our pipeline expected to launch within the next 5 years. We currently output close to 60 million auto-injectors in a year.
The production of an auto-injector begins in Sweden with research and development, where a team of designers and engineers work together to design an injector that balances efficiency, ease of use, and safety for the user. This is then created in computer-aided design, or CAD software.
So most auto-injectors look like a very typical pen. They have a cap, they often have a button at the rear end for activation, and they contain within them the glass syringe with a needle which contains the drug, and also usually some configuration of coil springs. They are a mechanical design, and then when the patient activates them, the springs then drive the syringe and the needle into the skin and then take care of the delivery of the formulation. Also, the devices need to take into account the patient and their needs. So we see many different varieties now in design of device to make better solutions so the patients can easily use them.
Once the 3D modelling has been completed and the form of the device is verified, the production process moves to Taiwan. Injection moulds are built here that correspond to the new device's shape. For every part within the auto-injector, a different mould is required. Heavy, high alloy steel is shaped using techniques such as CNC machining, grinding and electrode milling to bring the mould close to its final dimension. These moulds are heat-treated to increase durability and then finished in processes such as cylindrical grinding and polishing that accurately create the 3D model shape to 1/1000th of a millimetre. After being assembled, these new moulds are then installed into an injection moulding machine. Here, raw plastic pellets are fed into a preheated barrel via a hopper, where they are melted, mixed and forced into the mould cavity. Here it then cools and hardens to the shape, size and configuration of this cavity. The advantage of using injection moulding to form the components of the auto-injector is that it is an extremely versatile process. Almost any shape of component can be created, dependent upon the mould and in high volume too. The newly moulded plastic parts are then lifted from the moulding machine by a robotic arm. It is time to assemble the product. The newly created plastic parts are sent to the assembly workers along with metal parts such as springs.
A typical auto-injector can have anywhere from 10 to 20 plastic parts. Key metal components such as springs act as the main power source for the device mechanism, where other metal parts help to align and secure the plastic parts.
All workers must be gowned in order to ensure a sterile working environment. The relevant components are placed into the assembly machine. A light signal then indicates the machine is ready to be activated, at which point the assembly worker presses 2 buttons simultaneously and the machine then automatically assembles the product. The next stage of the process is quality control. Operators collect test samples from the production line and bring them to the laboratory for testing and inspection. These tests must be extremely thorough to ensure safety for the user and eliminate the risk of the injector failing. Once the mechanical elements of the auto-injector have been assembled, they are then sent on to Florida, where the drug materials are added and assembly is completed. An operator prepares the machine and loads a nest of syringes onto it. He loads the front sub-assemblies into the machine, followed by the rear sub-assemblies. The machine then inspects the needle shield of the syringes. The injectors then go on to the final assembly and are ready for labelling, packing and shipping. The final product then emerges and the auto-injector is complete. The auto-injector, truly a wicked invention. Over 50 years ago, the idea that a family could sit in front of their television sets and watch a live broadcast beamed over from the other side of the world was all but fantasy, something dreamed of in science fiction books and films. Early television viewers would often have to wait for days if they wanted to watch footage from different continents, as tapes had to be shipped across the ocean. However, this was all about to change with the launch of the world's first artificial satellite in 1957.
The Soviets put the first ever satellite in an orbit around the Earth. Sputnik, as it was called. It went around the Earth a few times and basically didn't do much more, sent bleep radio signals that could be detected down in Earth. The Sputnik program really kind of made the rest of the world step up its space programs and try to get satellites and even humans in an orbit around the Earth.
Sputnik wasn't just a peaceful science experiment though, it had huge military implications. The launch of this satellite played a huge part in the Cold War between the United States and the Soviet Union. Sputnik became a symbol of Soviet military propaganda, an example of their technological domination over the West. The US military were alarmed by this sudden new potential threat from space. and the space race accelerated, with both countries firing satellites into the skies.
From those kind of initial days of the space program and the satellite program came then very quickly commercial applications for satellites, such as television and telephony, which were amongst the first applications for which satellites were used. People realized that if you have a satellite, what you can do is send a big, strong, wide bandwidth signal all the way up to the satellite and then distribute it across a wide area, which is ideal for things like broadcasting, without having, for example, to create a cable network on the ground, which is often much more complicated and expensive.
In July 1962, a small ball-shaped satellite was launched into the air, built by the communications company AT&T. Its name was Telstar. On the 23rd of the same month, America, Canada, and 16 countries across Europe were able to watch a live broadcast simultaneously for the first time, and with this, satellite television was born. This technology realised its true potential in 1969 as Neil Armstrong stepped onto the moon with the whole world watching, thousands of miles away back home on Earth. In the 1970s, broadcast companies began to capitalise on this potential, and the excitement of satellite television and the number of broadcasts and dedicated channels soon began to increase. So, how does satellite television actually work? There are 5 stages to how satellite TV is transmitted: the programming source, the broadcast centre, the satellite dish, and the television receiver. Programming sources are the suppliers of the actual television content, whether that is a live sports event, film, or program stored on a tape or hard drive. The broadcast centre is the central hub of the system. At the broadcast centre, the TV provider plays out recorded program content or receives signals from other programming sources and beams a broadcast signal to satellites above the Earth. The satellites receive the signals from the broadcast centre and rebroadcast them to Earth. The viewer's dish captures the signal from the satellite and passes it on to the television receiver in the viewer's house. The television receiver processes the signal and passes it on to a standard TV. So the dish on the side of your house is an important part of the satellite TV chain. But why is it round?
The satellite dish, it's looking at a specific point where the signal is coming from. It's usually parabolic kind of shaped form that concentrates the radio signal that comes in onto the receiver point, which you typically can see in front of the dish. And the dish is really all there about concentrating as much as possible of that signal to get as much of the signal and without too much noise into your receiver.
Like with the early broadcasts of the moon landings, it is at global events that satellite television truly comes into its own, with its power to unify the planet and effectively shrink the world. Now that is, truly, a wicked invention. We've seen that satellites are needed to help transmit television signals around the world. But why? It is all to do with a big obstacle that gets in the way, that we affectionately call the Earth. Our intrepid tester is going to demonstrate how it all works and why. The materials: the Earth, or rather a globe, as the real thing is a little too large to fit in the studio, cocktail sticks, blue tack, small mirrors, and a laser. The demonstration. The NPBC, or North Pole Broadcasting Corporation, is transmitting a program on polar bears to an eager viewer in South Africa. The problem: like all television radio signals, NPBC signal, here represented by a laser, are transmitted in a straight line, and the receiver needs to be in its line of sight to be able to capture it. Trees and mountains can be a problem, but the curvature of the Earth represents the biggest obstacle of all. The solution: use a satellite to effectively bounce the signal to the receiver. With our small mirrors representing satellites, how easy is it to get a signal to our polar bear aficionado in Johannesburg? To begin, satellites are placed in a geostationary orbit of 22,236 miles above sea level, which would put them about here. As our laser does not have enough power to fire a signal that far, we will place our satellites in a rather closer orbit on some space-age cocktail sticks. Most television signals will actually need a network of satellites to direct a signal around the globe, and our miniature mirrors will work in the same way. Each mirror needs to be carefully angled to receive and reflect the signal, which is quite a tricky procedure. But after many hours of careful, problematic placement, our signal has been successfully transmitted. Our NP-BC signal originates at the North Pole and is then passed on through the skies of central Mongolia, Libya, Somalia, the mid-South Atlantic Ocean, and finally, our lucky viewer in Johannesburg gets to watch polar bears frolicking in the Arctic tundra. So, television satellite networks, simply explained. Well, kind of. The space race has given the world many revolutionary inventions, products that have changed our lives for the better, sometimes verging on the miraculous. Memory foam is one such invention that has become the stuff of legend, a household favourite and an orthopaedic wonder.
Memory foam was discovered or invented by Charles Yost at NASA. He was trying to develop a foam or a material that would help astronauts as they go in their command modules and they're on takeoff, because a rocket is a big explosion, generates lots of vibrations, and they're under quite high G pressures. And it would then make it more comfortable for astronauts to survive the rigors of space.
NASA scientists and researchers spent several months trying to figure out how to achieve what at the time seemed like the impossible.
It was developed by taking polyurethane and injecting it with air, and this expanded the polyurethane. Polyurethane you may know as a plastic, and you can find it in hard wheels, and so it seems a strange system to use. But if you inject air into it, it becomes much more fluid, it bounces back. And it was originally known as slow spring-back foam, which literally described how it worked. It would spring back quite slowly, sometimes in the order of about a minute to spring back to its original shape.
It was a massive breakthrough, and NASA used the technology to give astronauts a more comfortable ride through the intense vibrations and the massive G-forces involved in their space flights. In the early 1980s, NASA decided to release the technology for commercial use. It was initially expensive and wasn't without its problems when it came to using it in commercial applications.
The first generation worked quite well, but it had problems because after about a couple of years it broke down. For people like NASA, that's not so much of a problem because they had a budget they could work with and they could replace it. It was only meant for short-term use. But for longer-term use in car seats, airplane seats, this became a problem. And they also released quite a few volatile organic compounds, which meant they smelled little, they were potentially carcinogenic.
Once the initial problems had been addressed, memory foam started being used successfully in a variety of products.
Memory foam today is used in a variety of situations. Think airline seats, think beds. Most train seats will probably have it nowadays. And for car seats, you can drive for longer without feeling aches and pains. For motorcycles, bicycle seats, anything where a person sits on it pretty much will probably have memory foam nowadays.
It has also been used in the medical field for patients who need to be immobile for long periods of time, in artificial limb interfaces, and even to help reduce the symptoms of fibromyalgia, a condition that renders the body super sensitive to external pressure.
The pressure that you have exerted on the mattress is exerted evenly back on you. And so in medical situations, this is great because bed sores or pressure points are alleviated.
In 2006, the problem of overheating was resolved with some very clever chemical science, the gel-visco system.
The reason why gel works well in memory foam is that the body's heat turns it from a sort of gel system to more liquid. Doing this requires heat, so that actually means it can sap away heat from your body and then transfer it throughout the memory foam and away from your body. It's a bit like certain materials are very good at doing this. If you put your hand on wood, it doesn't feel very cold. If you put your hand on steel, it'll feel cold even though they're both the same temperature because the steel is taking the heat away from you much more effectively. So altering the memory foam with gel or other properties allows it to wick away the heat.
Ironically, memory foam technology has even now come full circle and helps astronauts rehabilitate once they've come back to Earth.
It's also used by NASA to help astronauts after they return. Because if you put a 4-inch layer of memory foam on the floor, it's actually difficult to walk on because it's unstable, but that helps astronauts who've been in space, they're not used to gravity, to regain their equilibrium. The destabilizing property of the foam allows the doctors to work out what to do and helps the astronauts regain their ability to walk on Earth again.
Nowadays, the most common use of the memory foam is still in mattresses. This space-age technology may have been developed with astronaut safety in mind, but now it gives millions of people a good night's sleep around the globe, making memory foam one of the most comfortable, wicked inventions. G&G are a memory foam products manufacturer based in Wakefield, England.
G&G is an expert in foam technology. It manufactures mattresses for the retail sector as well as the medical sector.
Memory foam is used in a variety of products and applications.
Other parts of the business are the sports play and the sports foam. It's also been used for prosthetics, where you need your body to mould your artificial limb. So it's a multifaceted business in foam technology.
The process starts with a delivery of memory foam, which comes in the form of a large block. The foam block is placed on a large slicing machine, ready for cutting down. The foam is cut down into slices of varying thicknesses, ready for assembly. On a computer numerical control device, also known as a CNC machine, another foam block is cut into special customized shapes. These layers will make the mattress more breathable and aid cooling by adding ventilation.
We have spent a lot of time and research in working on the foam itself and working on the substrate, where we cut in air channels, we cut in pressure relieving channels, minimising the heat build-up and maximising the pressure relief.
The layers are stacked, ready for mattress construction. Foam sidewalls are glued to the mattress base using a special glue, which is applied using a spray gun. A structured core is inserted into the middle of the foam frame. It is cut into special shapes to provide stability, whilst also ventilating the mattress.
What a lot of people don't probably appreciate, a memory foam mattress isn't made all of memory foam. Probably 50% maximum of the product is memory foam, because what you do need is memory foam on the top surface of your mattress, where it gives you the pressure relieving and the cradling effect, but underneath that you do need a firmer foam, otherwise you would just sink into the memory foam mattress like a big thick bowl of porridge.
The edges of the foam mattress core are now trimmed down to the correct specified size, neatening off the finish. Now, the covers are applied to the mattress core. At this stage, the product goes through quality control check, ensuring the quality and size meets the specified standards. The mattress is then sent through a roll pack machine, where the mattress is compressed, rolled up tightly and sealed in a plastic package. The mattress is then labelled and given a final quality control check, before being packed in its transit wrap, ready for delivery.
Memory foam has certainly helped us in everyday products. Sleeping on a memory foam mattress significantly improves your quality of sleep, and as you know, good quality sleep gives you a good quality life. You wake up feeling refreshed, so that's one of the biggest developments in memory foam.
So there you have it, the memory foam mattress, originally invented for astronauts by NASA, now providing a good night's sleep to millions. So there you have it, a dash through the hidden history, super science and amazing manufacture of products that you use every day, but have never realised their amazing background. Auto injectors, satellite TV and memory foam, all wicked inventions.